Hello friends, in this video we'll learn about real number. This is chapter 1. We begin with two very important property of positive integer is Euclid division lemma method, and next one is fundamental theorem of arithmetic. We use fundamental theorem of arithmetic for two main applications. First one is revisiting irrational numbers, next one is revisiting rational numbers and their decimal expansion. Total 4 subsections are there under chapter 1. That one is real number. The first subchapter is Euclid division algorithm. Generally, Euclid division algorithm is a technique to compute the highest common factor of two given positive number. Recall that the HCF of two positive integer is the largest positive integer that divides both the two positive integer. Okay, let us play with two number of to find out the HCF. 135 and 225. We have to find out the HCF of this two number. How we can find out? We simply divide the number in prime factor form. How we can divide? Simply divide the lower value of numbers to find out the prime factor. 135, what is the lower value? 2. It can be divided by 2? No, it can be divided by 3. 3 into 45, 135. 3 into 15, 45. 3 into 5, 15. Then what is the prime form factor for 135? 3 into 3 into 3 into 5. Now, same method apply for 225. What is the lower value number? 3. 3 into 75, 225. 3 into 25, 75. 5 into 5. Now, what is the prime factors for 225? 3 into 3 into 5 into 5. What is common in both the numbers? In both the prime factor numbers? 3 into 3 into 5, 3 into 3 into 5. Then HCF of 135 and 225 is 3 into 3 into 5. That is 45. Now we apply Euclid division algorithm to find the HCF of both this number 135 and 225. Simply we use for this factor for this time. Okay. Now we apply Euclid division algorithm to find HCF of 135 and 225. We start with the larger integer, that is 225. Then we use Euclid lemma to get a particular form that I write down here. A equal to B Q plus R. Here B is divider and R is remainder. Okay, now we need to break down this 225. It is a higher value to break down in the form of 135. Now we add oldest method 225. How many times? By 1 times. How much remainder we get? 0, 9. Okay. Then in this form, if I want to write down 225, how we can write? 225 equal to 135 into 1 plus 90. Okay. Then now after that one is become divider and that one becomes remainder. This is step 1. Okay. For step 2, this one is become divider and this one become remainder. And now again how we can write down in this form? In first form we break down the 225 in the terms of 135 and remaining terms is the remainder. Now I need to break down 135 in terms of 90. How we can break down 90? I divided 135 by 90. 1 times 90, what is the remaining? 45. Then how we can write down? 90 into 1 plus 45. Okay. Now for second step, third step, first step, second step, now third step, 90 becomes divider, and 45 becomes remainder. In step 3, I break 90 in terms of 45. How many times? 2 times. I becomes 90. 0. Okay. Now we can get by division lemma method 90 equal to 45 into 2 plus 0. Okay. Notice that the remainder has become 0 and we cannot proceed any further. We can say HCF of 225 and 135 is the divisor of last stage. What is the divisor of last stage? 45. That one is HCF of 135 and 225. In both the method, you find the same value. So, through Euclid division algorithm, you can find out the LCF of any values. Let us solve questions of Euclid division algorithm. The first question is that use Euclid division algorithm to find the HCF of 196 and 38,220. Okay, now we apply the Euclid division algorithm in both these numbers to find out the HCF of this number. Since 38,220 is more than 196, so we apply the division lemma to 38,220 and 196 to get the particular form of Euclid division algorithm. What is the form? A equal to BQ plus R. How we can find out? Now we divide 38220 by 196. Then 1 times 196 and what is the remainder? 6, 8, 1. 2 come down. Now next 9 times. 9 times what we get? 96 into T4 1764. Okay, what is the remainder? 8, 9. Okay, now 2 comes down. Now 5 times. Now 5 times 5, 6, 8, 5, 30, 9, 80. Okay, total crossing. Now we write down the 38220 in the form of the factor of 196. How we can write down? 196 into 195 plus remainder is 0. Okay, the remainder has become 0. So our procedure stop here. Since the divisor at this stage is 196, then HCF of 196 and 38220 is 196. This is your answer. Okay. Now next questions. So that any positive odd integer is the form of 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some integer. Okay, let us assume what is the equation for Euclid division algorithm is A equal to BQ plus R, and here R is vary from greater than 0 or equal to 0 but less than B. Assume B equal to 6, then what is the value of R? R vary from 0 to 6. Okay, then R is equal to 0, 1, 2, 3, 4, 5, but not 6. It's less than 6, not equal to 6. Here equal to 0 and greater than 0. Okay, 0, 1, 2, 3, 4, 5. Here we assume A is any positive odd integer. Okay, then we write down in the terms of B and R. What is the value of B? 6q plus what is the value of R? Here 0. Next 6q plus 1, 6q plus 2, 6q plus 3, 6q plus 4, 6q plus 5. These are different values, different 6q, 6q plus 1, 6q plus 2, 6q plus 3, 6q plus 4, 6q plus 5. Okay, already we assume a is positive odd integer. A is odd integer. Then we analysis these numbers, 6q, 6q plus 2, 6q plus 4. Okay, look at here, 6q equal to 2 into 3q. Okay, now 6q plus 2, 2 into 3q plus 1. 6q plus 4 equal to 2 into 3q plus 2. Okay, all three numbers is divided by 2, so it cannot be possible an odd integer. So remaining numbers is 6q plus 1, 6q plus 3, 6q plus 5. It is a odd. Simply prove it is a. Therefore we can say any positive odd integer is of the form, which form? In which form we can write down? 6q plus 1, 6q plus 3 and 6q plus 5. That is asking question. 6 plus 1, 6 plus 3, 6q plus 1, 6q plus 3 and 6q plus 5. This proved. The question says, use Euclid division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. Okay, let's do solution. Let us start with taking a. Assume a is any positive integer. Okay, we apply division lemma algorithm here, so we can write a equal to bq plus r, and in lemma algorithm r is greater than or equal to 0 but less than b. Okay, again we assume here b equal to 3, then we can write down above equation a equal to 3q plus r, and r can write down here greater than equal to 0 but less than 3. Okay, since r, how we can write down greater than 0 or less than 3, the possible value of r is 0, 1 and 2. So this can be, what is the positive integer can be? A equal to 3q or 3q plus 1 or 3q plus 2. Okay, now they want to show the square of any positive integer. There is a positive integer, we assume that one is a positive integer, then square of that positive integer is a square equal to 3q square. For the first one, it is equal to 9q square. It is a multiple of 3, and what is remaining? 3q square. We assume x1 equal to 3q square, then 3 into x means the square of this positive integer is a multiple of 3, and x1 is any integer, so we can write down is a 3m. M is also any integer, so first one is proved. 3m means square of any positive integer is in the form of 3m. Now next, 3q plus 1, a square equal to 3q plus 1 square. Now break down 9q square plus 1 square and 6q. Now break down 9q square plus 6q plus 1. Common value 3 into 3q square plus 2q plus 1. This factor we can assume that one x2 is equal to 3 square plus 2q. then we can write down 3x2 plus 1. Okay, this a square, a is a positive integer, square of this value, and this is a break form of this positive integer, and then we do the square of this factor, then finally we get in this form 3x2 plus 1. We can, and x2 is a positive integer, an integer, so it can be write down 3m plus 1. Means in this form we can say the square of any positive integer is in the form of 3m plus 1. Okay, a square in the form of 3m plus 1. First one is a square in the form of 3m. Okay, now for next one, a square equal to 3q plus 2 whole square. Now break down 9q square plus 4, 3 into 2 into 6 means how much? 6. 12q. Now q square plus 12q plus 3. It can be written in the same way, same, only 4 divided into 3 plus 1. We divide the 4, 3 plus 1. Now in 3, from these 3 steps we can take out 3 common. What we remaining? 3q square plus 6q plus 1 plus 1. We assume x3 to 3q square plus 6q plus 1. Then we can write down x3 plus 1. Means here we can show here that square of any positive integer is in the form of 3, and it is a simple, we can write down the 3m plus 1. So in 3 steps we can easily prove the square of any positive integer we can write down in the form of 3m, 3m plus 1 and 3m plus 1. That one he want. The question asks us the square of any positive integer is either of the form of 3m and 3m plus 1. Here we prove square of positive integer in the form of 3m, another square of any integer is any positive integer is 3m plus 1, and third one is 3m plus 1. It is proof. So therefore we can write any positive integer is of the form 3m and 3m plus 1. Okay, next question in this division algorithm method is: an army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? Okay, question is not it is so simple, but it is looking too complicated. Okay, explain. There will be an army band member in front. There will be an army band member in front, and behind it contingent member of army. Let me tell you by drawing. Okay, this section, this front section is for army band, and back section is for army contingent member. Then they ask how many, what is the maximum number of columns in which they can march. Then you need to find out, and you can find out the solution with the trial and error method, but it is time consuming. So in this question we simply apply division algorithm. Okay, the two numbers are there, 616 and 32 members. Both are using both members use same place, but in the column basis. So we need to find out the HCF of both these numbers. Okay, then the number HCF of 616 and 32 will give the maximum number of column in which they can march. Okay, simply we use division algorithm. Okay, in division algorithm, small number, larger number is divided by the small number. What is the larger number? 616 divided by 32. Okay, how 1 times 32? What is the remaining? 9, 2, 6 down, and now 9 times 9, 18, and 288. What will remaining? 8. It is the remainder. Okay, then we can write 616 in terms of 32. 32 into 19 plus 8. This is step 1. In step 2, because why we are moving towards step 2? Because here remainder is not 0. Then what is the divisor? It is divisor. And what is the remainder? 8. Then 32 is divided by 8. 8 into 4, 32. Now we get 8 32. Now 32 in terms of remainder, 8 into 4 plus 0 means that is the HCF. What is the HCF of 616 and 32 is 8. Means we can say the 8 number of columns, 8 maximum number of columns in which they can march. The final answer is that 8 columns. Okay, let's take in the drawing we can that is the right or wrong answer is that we tally. Okay, 32 members in front. Okay, 8, if there is a 8 column, this means 1 2 3 4. 1, this is moving up to 8 and this is moving up to 4. Same manner, if I am moving here 8 means there is a 8 column in backside of army contingent members. Then how many members in that columns? 8 divided by 616 divided by 8. Okay, means 56 means 77 members in a single column. Okay, here 4 members, is 77. Okay, 8 rows, 1 by 1 by 1, then easily they can accommodate the particular space to march. So what is the maximum number for this column? Maximum number of column is 8 in which they can march easily. Okay, now next question is that is the last question in this division algorithm. What they ask in this question: use Euclid division lemma to show that the cube of any positive integer is the form of 9m, 9m plus 1 or 9m plus 8. Before this question we do the same question that for the square. Now we are moving, we do for cube. Okay, same procedure. Let us start. Let's start with taking a simple assuming a positive integer a. Okay, it is any positive integer. We apply division lemma algorithm in that. So how we can write b q plus r, and what is the value of r is greater than 0 or less than b. Assume b equal to 3. So what is the value of a equal to 3q plus r, and what is the value of r? It should be greater than 0 but less than 3. Then what is the value of a? What is the possible value of r? R equal to 0, 1 and 2 but less than 3, not equal to 3. 0 equal to 0 but less than 3. 0, 1, 2. Then what is the value of a? 3q plus 1 and 3q plus 2. In this question they want to show cube of any positive integer is in the form of 9m, 9m plus 1 and 9m plus 8. And what is the first value? A, and what is the value? 3q. A cube and 3q cube equal to 27q cube. 9, 3q cube. We separate only 9. Take out from 9 from this integer. Now we assume x1 equal to 3q cube and 3 and 3 9x1. Okay, from here it is proved the cube of this positive integer in this form, the possible form is 9x1, or we can say 9m is the first one. Okay, now next a cube equal to, for the next possible form 3 cube plus 1 cube. What is the formula for a plus b plus cube? I write down here for you: a plus b plus cube, a cube plus b cube plus 3ab a plus b. Okay, we apply this formula here: 3 cube 1 cube plus 3 into 3 cube into 1 into 3 cube plus 1. Then what we found out here: 27 cube plus 1 plus 9 cube 3 cube plus 1. Okay, 27 cube plus 1, 27 cube plus 9 cube. 3 terms. We take out from this 9 from these 3 terms: 3 cube 3 cube and cube plus 1. This can be an integer. We can assume them x2. 3 cube 3 cube plus cube. Then it can be written as x2 plus 1 and can be written as 9m plus 1 a cube. A is a positive integer. We assume a is a positive integer, and cube of this positive integer can be equivalent. It can be form of 9m plus 1. We can prove from this procedures. Now next, what is the value of a? 3 cube plus 2. What is the cube of that term? 3. We apply this formula here. Okay. Cube 36 cube. These 3 terms we take out 9. 29 3s are 6 4 cube. That's it. It is a combination of integer and can be integer. We can assume x3 equal to that can be written as 9x3 plus 8 cube of any positive integer in the form of 9x3 plus 8, and can be written as 9m plus 8. Okay, then 3, what they ask in question: the cube of any positive integer is in the form of 9m plus 1 and 9m plus 8. From this combination, this equation, we can say cube of any positive integer is in the form of 9m plus 1 and 9m plus 8.